Okay, so another method of looking to see if something has a charge is with a piece of apparatus called a pith ball. Okay, so what a pith ball is essentially a little sphere. It's better if I draw it. So there's a stand, okay, and this piece here is made out of metal, but actually it's not really important. The important part is going to be here. So at the end of a string, there is a little metal circle or a sphere. And this sphere is attached to a rod with a string. Okay, so how this works is when you bring an object close to this, you can see what happens. If it swings away, that means it's repelled, or if it swings towards it, that means it's attracted. So it's kind of a way to look to see if you have a negative charge or a positive charge to see if it will attract or repel other charges. Anyway, you'll see an example when I show you. Please make sure you watch the videos that I put up on D2L to match with this lesson so you can see all of these things in motion, okay? There's also a great simulator that I have linked, so you can check it out and you can create your charges and you can bring the little objects nearby. It's really nice to play around with. Okay, so anyways, this little piece, this little metal ball is used to detect charges. So if a charged object comes close, the neutral pith ball will be attracted, of course. If you remember when we were mentioning about attraction and repulsion, neutral objects are attracted to positive or negative charges. But once it's been touched, whatever object you touched it with, that is the charge that the pith ball will now take on. So here's charge by contact with a pith ball. So here we have a neutral pith ball and a negative rod. So if we touch the pith ball with this negative rod, electrons are going to go onto the pith ball. So now we have a negative pith ball and a negative rod. So what happens is when you try bringing this close, the pith ball is going to be repelled away because negative and negative will push away from each other. So it's kind of like a way to prove, okay, well, is this pith ball positive or negative? Well, we know it's negative because the negative rod made it repel. So I don't have a diagram of this here, but imagine if this was a positive rod, right? So maybe I'll draw it. So if we had a positive rod with a neutral pith ball, right? When this touches, maybe is there a way I can move it? No. So when this touches, so here's my pith ball and it's now going to touch the rod, right? The electron is going to move from the pith ball onto the rod. So now my pith ball would be positive and my rod is still positive. So what ends up happening is after you take it away, the pith ball is going to be repelled because this is positive and this is positive. So it's going to push away. It is repelled by the other positive charge. The most important thing to keep in mind here is that opposites attract like charges repel. It will help you to remember why something is jumping on or jumping off, or what happens when they push away and attract. Okay, so the next topic is looking at discharge. This is also referred to as grounding, okay? Or you can also refer to this as neutralization. Same thing. So electrical discharge is how, once an object has a charge, how that charge gets neutralized again. So let's say we have something that is a negative charge. How does that become neutral once again? Well, what ends up happening is the charges are transferred into the ground, which is why we sometimes call it grounding. So a classic example is, let's say you were walking on a carpet. Your socks are doing friction with the carpet. So what ends up happening is you have a charge because of your socks doing friction. So when you go to touch a metal doorknob, what happens is the extra electrons that you picked up from the carpet will go into the metal doorknob, and then that's when you would feel a spark or a shock. What's happening is you are becoming grounded. So discharging or neutralizing or grounding, there are two ways that this can happen. One is just naturally from exposure to air. So naturally something that has a charge, the charge will go away over time. The reason why is because there is moisture in the air, and actually on humid days where there's a lot of moisture and water in the air, the charge gets dissipated, or I should say discharged more quickly. So the more humid of a day that it is, the more that those electrons will basically be neutralized, or they'll move into the water. So the faster way of doing that, of course, sometimes you don't want to wait a couple of days, you want to neutralize something right away, we'd use grounding. So what that means is you connect a charged object to the earth through a conducting material. So sometimes this conducting material can be a metal doorknob. Sometimes this conducting material can be yourself, right? Sometimes you are grounded through when you're touching different objects. But essentially you need something that is attached to the ground. So this symbol, sometimes it's drawn like this too. This symbol represents this grounding. So it almost looks like an arrow pointing down, right? It's to represent that the electrons are moving into the ground, okay? So how does this work? So if the object is negatively charged, the extra electrons that are on that object will flow into the ground, right? So let's say we have a sphere that's negative, right? And I'm going to attach it to the ground. So see how here I'm showing one positive symbol and two negative symbols? So that extra negative symbol would basically move into the ground. If you have a positive object, what that means is there is not enough electrons to neutralize it. So the electrons flow in the opposite direction. So let's say we have something like this, right? Where we have two positives and one negative. An electron can actually come up from the ground and go onto this object to neutralize it. The goal, remember the goal of grounding is to make something neutral once again. So if it's negative, it has to get rid of the extra electrons. And if it's positive, it has to add in extra electrons until it is neutralized. So just a point of note here, the Earth, just so you know, like, well, where are these extra electrons coming and going from? Essentially, the Earth is so big, it is assumed that it is impossible to kind of keep track of the electron movement in and out. So it's not like these electrons kind of disappear. They do go into the ground, into the Earth. So if you're standing on the ground, essentially electrons can move through you and then into your floor, wherever you're standing. And then the floor is connected to the ground eventually. Like, you're not standing outside on dirt, right? You're standing, let's say, in your house, but your house is built into the ground, right? So eventually it does make its way there. So when we're talking about these electrons coming and going from the ground, just so you know, it's not like they disappear or come out of nowhere. They are coming from the literal ground, right? So our Earth. And the last topic here has to do with, well, what if we wanted to make static charge? What if we wanted to make a big volume of charges so we can run some experiments on it? So there is a way of doing that, something called an electrostatic generator. So think of it. It generates electrostatic charges. Sometimes they're called friction machines. This is kind of an old-timey one. Let's look at a more up-to-date one. I'll look at the bigger picture. So here we have a friction machine. So here you have a rubber belt that basically will rub against a Teflon, so essentially a type of plastic. So what happens is this belt goes up and down, right? Like, kind of loops around. and it causes friction between the belt and this Teflon roller or plastic roller. So what ends up happening is electrons are transferred onto the Teflon piece, which will then go onto this metal cover. This is called a Van de Graaff machine. You might have seen something like this at the Science Center, right? So if you're touching, this is like a Van de Graaff machine, what it looks like on the outside. This is what it looks like on the inside. So you have a whole bunch of friction going on the inside of this. The electrons then go into the person who is touching it, and then the electrons actually cause the person's hair to be standing up. So it's kind of fun to watch. But one thing to keep in mind when doing something like this is why you have to do it with somebody who knows how to use this machine, is that this person has a lot of extra electrons on them. So they have to neutralize themselves before they can walk away from this machine. Because what can happen is when the hand is taken off from this machine, it can cause a big spark enough that it can actually harm the person. Okay, so no, when you're working, this is generating a lot of friction and a lot of electricity. So remember, it's called a Van de Graaff generator. So this has to be done in a safe manner. Okay, but just so you know, like, what does this thing do? Essentially, on the inside, it's doing friction, creating lots of electrons, and the electrons can sometimes do funny things to our hair. So if you ever end up going to the Science Center, hopefully, maybe it'll be open this summer that you can go to it. But if you try this out, the best result for the hair would be to make sure you don't have any product in it. So no gel, no mousse, no hairspray, nothing like that. It has to be in its natural state. That's when it stands up the best. So these are called electrostatic generators. This one specifically that is used in modern times is called a Van de Graaff machine. And I'll also link a video so that you can see this in action.